In this video, I'll show you how to write the equation for a parabola in vertex form and standard form if all they give you is the vertex and a point that it goes through. Write the equation in vertex form of the parabola that has a vertex of 1, 2 and goes through the point 2, 5, or 2, negative 5, I'm sorry. First thing you need to do is go grab your vertex form of a parabola. Should be in your notes somewhere if you're in Algebra 2, maybe even Algebra 1. Sometimes it's called the HK form. And you learned a little bit about this, where the H and the K are the vertex, and this A is the number that controls what the parabola looks like whether it's opening up or opening down, whether it's skinny or whether it's fat. What we do know right now is we have the vertex, and I know that the vertex is the H and the K. So I can change this H and K in the formula to those numbers. In order to write the full equation, we have everything except the A. We need to find the A. That's why they gave us a point. We can use these numbers temporarily, just for a second, popping in the X and the Y, and then the only thing we don't know is the A, and we can solve for the A. You're not going to use the X and the Y in the final answer. We just need them for calculating the A, and then we pop that in there. The Y is negative 5, so it goes in the Y spot. The X is 2. Now everything is a number except for the A, which means we can solve for A. We're going to have to go to the parentheses first and do 2 minus 1. So we get 1. And we're going to square that, which is not going to be any big deal, right? That's just a 1. So then our next line is negative 5 equals A plus 2. Subtract 2 from both sides, and we get A equals negative 7. Excellent. Go back to what we were starting with, where we already knew the H and the K, because that's the vertex, and now we also know the A. Pop all the numbers in, and that is the equation of this parabola in vertex form. And if that's all they ask you to do, you're done. But sometimes they don't want vertex form. Sometimes they actually want standard form, which means you'll do all that. You get this in the vertex form first, because that's the easiest way to do it. And then you got to take this and simplify it so it's in standard, which is ax squared plus bx plus c. So in other words, we have to multiply this all out. Starting with the parentheses, x minus 1 squared, we have to start there. And we get y equals negative 7 times the quantity, x squared minus 2x plus 1. That's what you get when you square x minus 1, which is x minus 1 times x minus 1. You just FOIL that out, or however you learned how to multiply binomials. If you need a review on that, I'll drop a link in here somewhere, probably up in here. We still have the plus 2, just kind of coming along. And now we need to do distributive property, which means we're going to multiply this negative 7 times x squared times negative 2x and times the plus 1. We end up with y equals negative 7x squared. That's pretty straightforward. People start making sign mistakes when you get inside here. So it's negative 7 times negative 2x. Just keep the signs with the numbers that come after them, or the terms that come after them. Makes this simpler. So you see a negative times a negative, that makes a plus. And then the negative 7 times the positive 1 is negative 7. And again, the plus 2 is just coming along for the ride, except now it gets to play. And we're going to combine the negative 7 with the plus 2. And we end up with a negative 5 for that. Our final answer in standard form is this. Just to make the point, vertex form, standard form. But it's the exact same parabola. We just changed how we move some symbols around, we do some math to change the format of that equation. That might have seemed a little complicated, but believe it or not, that one was pretty straightforward. Let's do one that is a little trickier, so it feels like you've at least seen one like this. Write the equation in vertex form of the parabola that has a vertex of negative 3, 6 and has a y-intercept of 2. So a lot of prior knowledge goes in here. First of all, bring in your vertex form or your HK form, however you like to call it. We know what the vertex is. That's your HK is negative 3, 6, so we can pop those numbers in. That's going to change to a plus in a second, but just to be super clear, I am always subtracting in the actual formula. But when you are subtracting something that's negative, you're going to see a sign change here in the next line. Let's deal with this y-intercept of 2. I needed a point, and they say the y-intercept is 2, so you have to remember from algebra that means the coordinate for the x is 0. If x is 0, y is 2. That makes it a y-intercept. So your x is 0, your y is 2, and I can rewrite this now, substituting in the 2 for the y. We still don't know a. We're going to figure that out in a second. I took care of the double negative right here, made it a plus, and the 0 for the x right there. The 6 still is my k. So once you have all these numbers popped in, the only thing you don't know is the a. So we'll try to solve for that. Dealing with the parentheses first, we end up with just a 3 getting squared there. So that's going to give us 9a. So 2 equals 9a plus 6. Okay, this is starting to stink a little bit, but it's going to get ugly here in a minute. We're going to subtract 6 from both sides. This is not the ugly part. 2 minus 6 is negative 4. Here it is. We're going to have to divide both sides by 9. So our a is turning out to be negative 4/9. For right now, that's not too bad because all we're going to do with it is pop it into that vertex form. So let's scroll back to that, popping in numbers that we need for the equation. Remember, we're going to, for the actual equation for your answer, you leave the y and the x in place. We only used them in the middle there just to solve for a. But now that we know what a is, we'll just pop everything in there. Let me put that plus back in there for the double negative. And so this is your final answer in vertex form. And if you're lucky, that is all you have to do. But so you don't have to do it, I will. We're going to take this bad boy and put it into standard form. I'm going to multiply every single term times that denominator 9. And I'm doing that for one reason. When you multiply a fraction times its own denominator, it cancels the denominator, and you're left with just the numerator as an answer. Shortcut that I think everybody in high school wants to know. If they don't, they need to know this. So let's just finish the multiplication here. We've got 9 times y, 9y. We end up with this negative 4 left, but it's still multiplied times the quantity x plus 3 squared. Notice in this last line I bracketed that whole thing. This is one whole term, because this 4/9 times this squared thing is one term because they're being multiplied. So now I have the negative 4 times that, and then 9 times 6 is 54. Expand that. We need to multiply x plus 3 times itself, and we end up with 9y equals negative 4 times x squared plus 6x plus 9 plus the 54. Now you need to do distributive property again. And we get 9y equals negative 4x squared minus 24x minus 36. And the plus 54 is just tagging along. But now we need to deal with it. So the next line is 9y minus 4x squared minus 24x, which is all just copied. And then the negative 36 plus 54 is just a positive 18. You'd like to be done, but you're not, because standard form doesn't have 9y equals something. It needs to be 1y. So even though we got rid of the fractions just to work with it, they keep coming back and they still smell pewy. But some of this stuff is going to cancel nicely and some not so nicely. 9y divided by 9 is just going to be y. The 4/9 there, it comes back. It's like you can't get rid of me so easily. And then we have 24/9 x, and then 18 divided by 9 is 2. That's nice. And you think you're done, but no. So you have to reduce that, the 24/9, and that reduces to 8/3, 8/3, 8 turds. That's turds. No wonder it stunk, right? Now you're finished. That is in standard form. So this was your vertex form, and there was your standard form. But it's the same parabola. Thank you for watching. I'll see you in the next one. Good luck in your Algebra 2 class if that's what you're in right now. Bye.